Hello everyone, and welcome to this new video tutorial for Maverick Render. This tutorial is an introduction to Maverick's new multi-clone feature. The multi-clone modifier is an easy but very feature-rich way to create product arrays for highly attractive marketing presentations. These images are all example arrangements created with the multi-clone feature. Let's see how this works so you can create your own. Multiclone is an object modifier which can be added to a scene in two ways. The first way is to pick an object and then select Create and Connect from the context menu. As you can see, multiclone spawns an array of clones right away. You generally want to hide the multiclone gizmo from the Scene Explorer. Movement-wise, multiclone is bound to its parent like any other modifier. The second way to create a multiclone modifier is from the toolbar in the Objects panel. Once created, it can be dropped to an object or an object group like we will do in this case. This will automatically spawn an array of clones of the source group. Let's now walk through the multiclone attributes. Let's create and connect on our primitive here and hide the multiclone gizmo. The multiclone attributes are revealed in the attribute editor. This node is very attribute heavy, but these attributes are generally easy to understand if play with them one by one. Let's begin with the instance counts. You can tell here how many instances you want per axis. The attribute to the left defines the growth of the array on the negative direction and the one on the right the growth on the positive direction. It is easy to get an intuitive understanding of these by stepping up or down the values yourself. Let's constrain the modifier to create instances along the Z-axis only. We have 5 instances plus 1, which is the source object itself. Let's hide the room to better see how the arrangement grows upwards and also downwards. Remember that everywhere in Maverick, right-clicking on a spinner or a slider resets the value to its default state. These checkboxes are a feature called stacking, which makes sure that instances are tightly packed one next to the other. By toggling these off, we can freely choose the separation between instances ourselves. In the control rollup, we can adjust the rotation of the whole array of instances, or the instances themselves. Let's disable instances along the Z-axis. And now rotate them about the Z-axis. As we can see, the source object won't rotate, as it doesn't really belong to the array. For the source object to belong to the array, we have this overlap checkbox here. Be careful though, because now we're creating an instance that coincides with the source object, so you may want to hide the source object itself. Now everything is working the way we want. The polar rollup can be used to create circular or cylindrical arrangements. Let's disable the Y-axis to have a single row of balls. With polar enabled, we will see how the instances arrange circularly. You may change or flip the radius. From this particular viewpoint and with the radius flipped, we can clearly see the effect of the reorient to center checkbox. The angle can be interpreted as a rotation offset from one instance to the next, or as the total rotation angle. For example, let's choose 360 degrees and increase the instances count. There are also attributes to create spiral or helicoidal arrangements easily. We encourage you to test drive all the options yourself. The hollow roll-up can be used to create tubings, walls, or frames. These counts here remove instances from the original lattice and can be used for creative purposes. The box frame feature produces a hollowed-out box with hollowed-out faces as long as the original lattice provides enough instances itself. In order to complete the box frame, you need to grow the lattice at least 1 unit on the negative side of either axis. Just try some options to see what they look like. The skew roll-up can be used to create pyramidal arrangements. When enabled, it trims out instances producing a slant lattice as long as the lattice provides enough height itself. There are count and offset controls to clip or shear the top of the pyramid. The zipper roll-up can be used to interlace rows or columns. The interlacing will happen in a direction that depends on the plane selected. You may configure the amount of shift with the offset value. You may also rotate or scale the shifted rows. Multiclone provides random translation, rotation and scaling features similar to those in the scatter node. Basically, each pair of attributes here defines a randomization range. We have introduced a step value in the random rotation rollup to constrain rotations to a set of predefined values. Randomized scale is less useful in multiclone because you generally don't want the clones to change in size. To bookend this walkthrough, we will learn how to randomize the color of instances created with multiclone. Let's select this metal material and save the current color in the color editor with the eyedropper tool. Now let's connect a color general node to the diffuse color plug. Now we can retrieve the color we saved and randomly affect the hue, saturation or lightness easily. Finally, we will learn how to convert multiclone instances to actual polymesh geometry. Let's constrain instances to the X and Y axes and click on Convert to Polymesh. We will end up with a group where all the instanced clones have been converted to real polymesh nodes so they can be moved or edited independently. Note that the color general node no longer works because it was set to randomize by instance ID and we no longer have instances. We can fix this by changing the randomization mode to object ID. Now we can move, edit or delete each clone independently. In the next few videos we will see real cases of use of the multiclone feature. This is all for now. See you in the next video. Have fun rendering with Maverick.